Hello everybody, my name is Jeffrey, and in this tutorial we will apply some transformation matrices to our vertices. So what we're going to do is we're going to create a new class. We're going to call it the transform class, and we're going to create it in the maths package. In that class we will have a few static methods which will they will basically be utility methods and makes things a lot easier for us later on. So we're going to create that class, so go over to your math package and create your transform class. So basically all we're going to do this tutorial is we're going to create a public static matrix for f. It's going to return matrix for f, and the method is going to be called get transformation. And we're going to take in a few variables, for example a vector 3f translation, a vector an float value for the scale. We're going to take that in as the final variable. The second, third and fourth will be the rotation. So first float rx for rotation on the x-axis, then float ry and float rc. And that's all we're going to take in for now. And we'll have to create some matrices. So matrix for f translation matrix equals new matrix for f dot init translation, and just give it the translation matrix. And that's the first thing. I'm going to return null for now because that error is going to bug me. Yeah. The second transformation matrix will be matrix for f rotation matrix equals new matrix for f dot init rotation, and we'll just give it the rotation on the x-axis, the rotation on the y-axis, and the rotation on the z-axis. The third matrix, matrix for f scale matrix, equals new matrix for f dot init scale. And well, that's it. Those are the three matrices that we're going to make. If you're interested in how these matrices work, it's not very hard. I suggest you look it up. I will try to put a link in this description, which has to a page which has a good tutorial, if I find one. But yeah, it basically, if you already know some things about matrix multiplication and things like that, then just look at this and you'll be able to understand what it says. So go back to your transform class, and now we want to multiply these matrices in order to return one big matrix. But we can't just return we can't just multiply them in a random order, because there is a certain order of operation you have to follow. You have to apply rotation and scale first, and after that we can apply translation, because otherwise it would translate the object first and then rotate it around its origin. So for example, if we moved an object to an x coordinate of 10 and we rotated the object on the y-axis with a angle of 180 degrees, the new x value would be -10, and that's not what we want, because we want the object to rotate at its x at the x value of 10, but not around its origin. So that's why we're going to apply the translation at last. I hope this was a bit clear. Well, this is basic maths, so if you don't understand it, again, look it up on the internet. There are a lot of tutorials, just like this tutorial, but my tutorial is more on how to create the game itself and not how every single little thing works. So, okay, the first thing that we're going to do is we're going to type translation matrix dot multiply, and we're going to multiply by the rotation matrix dot multiply by the scale matrix. And well, now you might be thinking, well, Jeffrey, why are you multiplying by the translation why are you writing the translation matrix first? And that's just because that's the way I wrote the multiplication method, and that's why I have to write them in this order. So basically those are that's our transformation matrix. So go over to your shader class, and we're going to create a new uniform. Well, we're going to change the previous one, and we're going to call this world matrix. And we're going to change it over here as well, and update world matrix. And we're going to take in a for the 4x4 matrix, so matrix 4f world matrix. Copy it, paste, and import matrix 4f. And that's it for our basic shader class. Now we'll have to do things over here, so I'm going to type basic shader dot update world matrix transform dot get transformation new vector 3f 0, 0, 0, 0 and 1 for the scale. And we're going to I want to finish off my vector class, so yeah, and open up your notepad and open up your shaders, and we're going to change this so we won't be using this color uniform anymore, and I'm just going to set the color to white for now. And we're going to take in a uniform, a matrix 4f, well, a 4x4 matrix uniform, and we're going to call it world matrix once again. And an important thing to note is, well, we're going to multiply our position by the matrix so that we get the new position out of it, but always put your matrix first and then vectors, and that's pretty important with matrix vector multiplication. So world matrix times this, and yeah. And that should do the trick. So if I go ahead and click on the debug icon, I should now be able to move this thing around. So if I type in a 1 over here and save it, as you can see, oh no, I did something wrong. Stop. I have to type an F after that. So 0.5f, it's only over there, and I can make that negative. So -1 and it puts it over there. Yeah, and basically rotation and scaling also works. So x, y, we're going to rotate it around the y-axis, which for now will basically mean that because we're using a 2D triangle, it basically means that we're scaling on the x-axis. So I'm going to rotate it about 45 degrees, and you as you saw, we scaled it with well, we halved its width. So yeah, but that's transformation matrices. In the next tutorial we will be using indices, and the tutorial after that we will probably apply a perspective projection matrix. Yeah, so I hope I see you in the next tutorial. Bye!